117 of Neetcode 150, longest repeating character replacement. We are going to be given a string just like this. And basically they ask us, if I give you a value k that represents the maximum amount of modifications you can do in your string, what is the longest substring um, of identical character that you can come up with? Okay, so here if our string is x, y, y, x, well, we have two modifications. Okay, k value is equal to 2. Well, we can replace both x by a y, or we can replace both y by a x, and it's going to give us a string of identical characters of length 4. All right. This is the example 2. We have a string a b b, and we have one modifications. Well, we can see right away with our human brain's intuition that if you replace the b in the middle by a, you're gonna have a string of 5 a's, which is definitely the longest string you can come up with. So this is it. But the challenge is how to implement this in code. So we're gonna have to use a sliding window algorithm. We are gonna have a dictionary with our keys and our values. We are gonna have what I call the left pointer and the runner, and they're both gonna start at index 0. And we are gonna add in our dictionary the index 0 value and its count. So for the first round, a has a count of 1, right? Okay. And basically what we are going to do is that we're going to take the length of the current string. So it's basically the index of the runner minus the left index plus 1. So here it's 0, 0 minus 0 plus 1. All right, so the length of the string is 1 character, it's 1. And we're going to subtract that 1 by the most frequent element. Here it is a, which is 1. So 1 minus 1 is 0. So basically it tells us that we need 0 modifications to have a string of unique character. All right, so the check here will be, is that difference smaller or equal to k? In our case, it is smaller than k, so we can continue. So we're gonna push our runner forward by 1. It's another a, so we're gonna increment the value of a by 1. We're now at 2. Okay, so we're gonna take same principle, the length of the string. So it's gonna be the index of the runner 1 minus the index of the left pointer. So 1 minus 0 plus 1 is 2. Now 2 minus the most frequent value, it's 0. So you need basically 0 modifications to have a string of unique character. Good, so we can move to B. We're gonna add B in our dictionary. Okay. There you go. And the most frequent element is still A. Okay. So we're gonna take the length of the current string. So it is 3, right? So the length of the string is 3, and we're gonna subtract the most frequent element, which is A. So 2. 3 minus 2 is 1. So you basically need one change here. It's gonna be that little b, and if you change that b to a hey, you're gonna have a string of unique characters. So if we're given a k value of 2, right, we can definitely make a string of unique character. That's not a problem. So we're gonna continue. We're gonna face a C. Okay, so we're gonna add the C. Great. And the most frequent element is still A. And the length of the string is 4. 4 minus 2 is 2. And basically this tells us that we need to change 2 characters to have a string of unique characters. And we are allowed to change two characters, so we are still good until we get that D. So we're gonna add D. All right. But now the length of the string is 5, and the most frequent value, which is A, is 2. Okay, it occurs 2 times. So you have to change 3 characters in order to have a unique um, string, a string of unique characters, and we are not allowed to do that. So um, here comes the here comes the challenge. How are we going to overcome this challenge? We are going to take our left index and we're going to move it by 1 to the right. We're going to decrement the value of A by 1. Okay. And notice that at this point, we don't even need to update the value of the most frequent element because because after this example is not good to express what I mean, but let's say here we have a z, for example. Well, we're gonna add our fifth character, and since the maximum, the most frequent element in our case will still be our previous two, well, we are gonna have to move our left pointer by 1 to the right. So we are never gonna have a string of 5 characters. So we don't even need to care about updating or decreasing the maximum frequency. We only care about increasing it in the case where we actually have a greater frequency than the previous one. Okay, so in this case we have another A, so we're going to increment its value. Great. And the most frequent element is still A, and we have a string though by of 5, so we still have to move our left pointer by 1 here and decrement the last value by 1, right? And now we are not gonna move the left pointer by 1 to the right because we are gonna keep our previous value of 2. As I mentioned, we're not gonna decrease it, and this is perfectly fine. So we're gonna move again our pointer to the C. The C is already here, so we are gonna increase the C by 1. The most frequent element is still 2, so our C didn't beat our previous A. And we have a string of 5 characters, so we still have to move the left pointer to the right. Good, so we're gonna keep doing this until we beat the longest string of 4 characters that we had. And if we ever beat it, we are gonna return the longest one. So how can we code this? First, we have to create our dictionary. Let's call it count. We're gonna have to create an output, okay, to or just response, or let me call it answer. It's gonna start at 0. We're gonna have to create our left pointer, which is 0, and we also have to keep track of the maximum frequency. So let's call it max f, which will be set as 0. And now we have to move our runner forward. So for r in the range of the length of s, we are going to add to the dictionary count the value of the string at the index of the runner. And this is going to be equal to 1 plus whatever the value is at the index r of the string. And we're also going to we're going to set a default value of 0. And this is where we can check if we have a number that has a greater frequency than the previous greatest frequency. So what we're going to do is that we're going to just check if the basically the count of the new of the string at the new index of the runner is greater than the count of the maximum count. Okay, so just like this. And after this, we are gonna take the length of the string and we're gonna subtract the maximum frequency to see like how many characters we actually have to change in order to have a string of unique character. So while we're gonna basically while loop the condition where the the number of characters you have to change is greater than the k values we're given, and by doing this we're going to move our left pointer to the right and we're going to decrease the count of the string at the index of the left pointer. So while the basically the length of the string, which is the runner index minus the left index plus 1, so while this length is well minus the max frequency, while all of this is greater than our k value, all right, what do we do? Well, we decrease the count in the dictionary where the key value is the value of the string at the index of the left pointer. So we're going to decrease it by 1. And we're going to move our left pointer to the right. And the answer is going to be the answer, which is the longest string, is basically going to be the longest string between our previous answer and the runner index minus the left index plus 1, which is the length of the current string. Okay, and we are going to return the answer. And why does this work? Let's say we take this example. So we first start with A. We go for the second A. We go for the third A. We have a frequency of 3A here. This is going to be our maximum frequency for the entire for loop, for the entire check. After this, we're going to go see B. We're going to go see B. And I didn't specify it, but let's, for the sake of the example, let's say that k value is 2. So we got our 3 A's. Now we have a B and another B. So we have 2B. Our k value is 2, and the length of the string, which is 5, minus the most frequent element, which is A, that appears 3 times, is 2. So we can actually afford or 2B in the string. But after, when we add this C, well, we have to make 3 changes, okay, to have a string of unique characters. So what we're going to do, well, we're going to decrement the count of A by 1, and we are going to also move our left pointer just like this. All right, and now the count of the most frequent element is still going to be 3, because we're not going to decrement it at any moment in the code, and we are going to take our extra character here. So we're going to have a string of 6 characters, and we're going to remove it by our most frequent character frequency, which is still 3. It's going to give us 3, right? 6 minus 3, 3. So we don't have 3 change to afford this, so we're going to move our left index to the right. So we're going to be here. So we still have 5 characters in our string, and when we're going to take our S, same thing is going to occur. We have a string of 6 characters of length, and the most frequent character is still our 3, so we have to shorten it. So we are never going to get a string of 6 characters. So this is the reason that we can afford um, never decreasing the max frequency, only increasing it if the frequency of the element at the random index is greater than the previous maximum frequency. Okay, so this is the solution to what we have an error count. Oh, I forgot. Okay, I apologize. There's no indenting. There you go. Okay. Uh, Invalid syntax. One, I forgot my plus. All right. Let's see it work. Great. All right. So forgive me for my syntax errors. The logic still works. So I hope you learn from this video, and I hope to see you in the next one.